Hello everyone and welcome back to another math video. In this video we are going to talk about how do we solve a two-step equation. So with the two-step equation we're going to see the variable multiplied or divided by something, and then that term is going to be added or subtracted to something else. So I want you to think about like an onion, and we're going to peel off layers. We're going to peel off layers. The first layer we're going to peel off is whatever is added or subtracted. Remember, we're always thinking about this idea of using opposites. And then after you peel off the added or subtracted term, then you're going to deal with the multiplication and division, and that's going to get that variable by itself. So let's look at a few examples. In the first one, we have 3 times x plus 5 equals 20. So I'm going to draw my wall around my equal sign. Remember, to cross that wall, you have to do opposites. So the first thing I want to do is to peel off that outside piece, which is that 5. So I'm trying to get this 3x by itself. And to do that, I've got to undo this. And that's going to get the 3x by itself. And then I can focus on getting the x by itself. So to peel off this layer, I got to do the opposite. Is added. So the opposite's going to be the subtract. So now I have positive 5 minus 5, which zeroes out. On that left, I just have a 3 times x left. On the right, 20 minus 5 is 15. And then now we're going to do another opposite. We have 3 times x, and the opposite of times or multiplication is division. What I do to the left, I got to do to the right. Notice I'm writing it on both sides of the wall. Math is always fair. So 3 divided by 3 is really 1. So this is really a 1 times x, which is x. 15 divided by 3 is 5. And again, if we wanted to check our answer, we could. I'll check this one just so you can see how to do it. So we have 3 times x plus 5 is equal to 20. We said x is equal to 5. So let's plug it in. So we have 3 times 5, and I'm going to put times 5 this way, which is the parentheses around the 5, plus 5, and we want to know, is that equal to 20? Remember, please excuse my dear Aunt Sally. Do parentheses first, exponents, then multiplication and division as it occurs in the problem. 3 times 5 is 15. And now we're going to add that 15 to that 5. That's addition and subtraction occurring as it happens from left to right, and 20 is equal to 20. So we know that that's the right answer. Let's look at the next one. We have negative 2x minus 7 equals 9. I'm going to start by drawing my wall. So we're going to do opposites. I got to get this by itself, and this is called a term because it's separated from that 7 by a subtraction sign. Just like above, that 3x is a term because it's separated from that next one by an addition sign. If it's separated by addition or subtraction, those items are called terms. So let's try to get this by itself. I got to do opposites. The opposite of a negative 7 is a positive 7. What I do to the left, I got to do to the right. Math is always fair. So negative 7 plus 7 is going to cancel. So we're going to have minus 2x left on the left. 9 plus 7 is 16. So we're going to have 16 on the right. And then we're going to perform another opposite. That negative 2 and that x are being connected with multiplication. The opposite would be dividing. Negative 2 divided by negative 2 is a positive 1, so this is really 1 times x, which is x. 16 divided by negative 2 is going to give us a negative 8. So we're going to get x equals negative 8. In example 3, we have x over 3 plus 4 equals 10. So we're going to think about peeling off the layers. That first layer is that plus 4. Here's my wall. The opposite of adding 4 is subtracting 4. What I do to the left, I got to do to the right. So now I have x over 3 on the left. 10 minus 4 is 6 on the right. And then we're going to do another opposite. The relationship between the x and the 3 is division, right? That's what that bar means. So the opposite of dividing is multiplying. What I do on one side, I got to do on the other. So now I have a 3 at the top of the fraction and a 3 in the bottom of the fraction. 3 divided by 3 is 1. 1 times x is just x. And 6 times 3 is going to be 18. So we're going to get x is equal to 18. And again, you can always check it. So we have 18, because I'm just going to plug that in for that x, over 3 plus 4. We want to know, is that equal to 10? If we're using that, please excuse my dear Aunt Sally, we do multiplication and division first as it comes in the problem. So we have a division. 18 divided by 3 is 6. And then we're going to do the addition. 6 plus 4 is 10. And we know 10 is equal to 10. So that means our answer of 18 is correct. So here's a few where you may want to pause the video, try it, come back and check your answers. So in this one, the goal is to get the 4 times x by itself. I'm going to start by drawing my wall. I've got to move that minus 6. The opposite of subtracting 6 is adding 6. So I got to do it to both sides of the wall. Negative 6 plus 6 zeroes out. So I have 4 times x on the left. 18 plus 6 is 24. So now I have 4 times x equals 24. The opposite of multiplying is dividing. So now I have 4 divided by 4, which is 1. So I have 1 times x, so that's just x. 24 divided by 4 is 6. So x is equal to 6. And that next one, I have negative 5x plus 3 is equal to negative 22. Again, I'm going to draw my wall. So I've got to peel the layers off. The first layer is moving this term, which is that positive 3. Opposite would be subtracting. So I have positive 3 minus 3, which is 0. So it's going to leave me with that minus 5x on the left. And then negative 22 minus 3 is a negative 25. So now I have negative 5x equals negative 25. We're going to do the opposite. We're going to divide by negative 5. So we're going to get x on the left. Negative 25 divided by negative 5. A negative divided by a negative is a positive, so that's going to be a positive 5. So there's our answer. So let's do another one. So in the other examples, that term with the variable was first. Let's do a couple with the term with the variable is actually second. So I've got negative 4 minus 5x equals 31. It's going to work the same way. So I'm going to start by drawing my wall. I'm going to do opposites. I want to get the term with the x by itself. So I want to keep this over here. I want to move this 4. So how do I move it? Well, right now it's a minus 4. To zero out, I need a plus 4. What I do on the left, I got to do on the right. Math is always fair. So look, negative 4 plus 4 is going to zero out. I'm going to be left with a negative 5x there. And then 31 plus 4 is a 35. So now I have negative 5x equals 35. And I'm going to divide by a negative 5. I'm doing opposites. I have negative 5 times x. And the reason I'm choosing division is because the opposite of times, or multiplication, is division. Now those negative 5s are going to cancel out. Negative 5 divided by negative 5 is a 1. So this is 1 times x, which is x. And then 35 divided by 5 would give me, 35 divided by negative 5 would give me a negative 7. Okay, so you're probably asking, well, why did I choose a positive 4 here? Why would I not choose a negative 4? You could always try it and see what happens. Let's try that again. So I'm going to draw my wall. What if I would have chosen a -4 here? Look at what happens in that first step. -4 minus 4 is a -8. It didn't zero out. So if it doesn't zero out, then you can't use that technique. You got to try, or that term, you got to try something different. So that's why we had to have a +4 here. It can get a little tricky. Let's do another one. What if we have -7 plus 2x is equal to -9? So we're going to use that same technique. I'm going to start by drawing my wall. So here's my wall. To cross it, we have to do opposites. So I want to get this guy by itself, which means I got to move that -7. So you got to think, what can I do to move the -7 to zero it out? I'm going to add 7. -7 plus 7 is going to zero out. That's going to leave me with a 2x. -9 plus 7 is a -2. And then we're going to do the opposite. We have 2 times x, so the opposite is dividing. And that's going to leave me with x equals -1. Okay, again, you got to be careful because it would be really easy. Let's revisit that one. We have -7 plus 2x equal to -9. I draw my wall. So it would be really easy to try to use that sign in front of the 2x instead of the sign in front of the 7 there. So what if we tried that? What if we did -7 on both sides? Look how it's going to fall apart. -7 minus 7 is a -14. And notice I didn't get just the 2x by itself. I now have added 7 to both sides. So that's not going to help me solve, all because of that sign. That's why we have to have a +7 and not a -7. So be careful with those as you're working through.